Welcome to this video. Today our topic is control valve. Introduction. Control valves are essential components of many industrial processes that require precise control of flow rates, pressure, and temperature. In this video, we will discuss the basics of control valves, their components, and their operation. What is a control valve? A control valve is a device that regulates the flow of fluid in a process system by varying the size of the opening through which the fluid passes. The valve is controlled by an actuator that responds to a signal from a controller. This controller monitors the process conditions and adjusts the valve position to maintain the desired process parameters. Components of a control valve. Control valves are made up of several key parts, each of which plays a critical role in their operation. Here are some of the main parts of a control valve. 1. Valve body. The valve body is the main part of the valve that contains the flow path for the process fluid or gas. 1. It is typically made of a durable material such as cast iron, stainless steel, or bronze, and can be designed in various shapes and sizes depending on the application. 2. Trim. The trim is the internal components of the valve that regulate the flow of the process fluid or gas. 2. It typically consists of a valve plug, stem, and seat, and may also include other parts such as cages, discs, and bushings. 2. The trim is designed to be interchangeable so that it can be easily replaced or modified to suit changing process conditions. 3. Actuator. The actuator is the part of the valve that translates the control signal into the movement of the valve plug. 3. It can be either pneumatic, hydraulic, or electric, and is typically mounted on top of the valve body. 3. The actuator can be designed to be fail-safe, meaning it will automatically move the valve to a safe position in the event of a power failure or other emergency. 4. Positioner. The positioner is an optional accessory that is often used to enhance the performance of the control valve. 4. It is mounted on top of the actuator and receives a signal from the control system, which it uses to adjust the position of the valve plug. 4. The positioner ensures that the valve is accurately positioned, even in the presence of changes in the process conditions or external factors such as vibration or temperature. 5. Bonnet. The bonnet is the part of the valve that covers the top of the valve body and provides a connection point for the actuator and positioner. 5. It can be either bolted or screwed onto the valve body, and may include features such as packing glands or bellows to seal the valve stem and prevent leaks. 6. Packing. The packing is a sealing material that surrounds the valve stem and prevents process fluid or gas from leaking out of the valve. 6. It can be made of various materials such as graphite, PTFE, or braided rope, and is typically compressed against the stem by a packing gland. 7. Spring. The spring is a component of the actuator that provides the force necessary to move the valve plug. 7. The spring can be preloaded to a specific force or range of forces, depending on the process requirements. 8. Handwheel. The handwheel is an optional accessory that can be used to manually open or close the valve in the event of a power failure or other emergency. 8. It is typically attached to the top of the valve stem and can be turned to rotate the valve plug. 9. Flow straightener. The flow straightener is an optional accessory that can be used to improve the flow characteristics of the valve. 9. It is typically located upstream of the valve and is designed to reduce turbulence and promote laminar flow. 10. Position transmitter. The position transmitter is an optional accessory that can be used to provide feedback on the position of the valve plug. 10. It is typically mounted on the actuator and sends a signal to the control system indicating the exact position of the valve. 11. Flow restrictor. The flow restrictor is an optional accessory that can be used to regulate the flow of the process fluid or gas. 11. It is typically located downstream of the valve and is designed to reduce the flow rate by creating a pressure drop across the valve. 12. Characterized trim. The characterized trim is an optional accessory that can be used to modify the flow characteristics of the valve. 12. It is typically used in applications where the flow needs to be controlled in a specific way, such as in mixing or blending processes. 13. Diaphragm. The diaphragm is a component of the actuator that separates the process fluid or gas from the internal components of the actuator. 13. It can be made of various materials such as rubber, PTFE, or metal, and is designed to be flexible so that it can move in response to changes in the control signal. 14. Solenoid valve. The solenoid valve is an optional accessory that can be used to control the flow of air or hydraulic fluid to the actuator. 14. It is typically controlled by the control system and can be used to open or close the valve or to adjust the valve position. 15. Transducer. The transducer is an optional accessory that can be used to convert the control signal from one form to another. 15. For example, it can convert a pneumatic signal to an electrical signal, or vice versa. 15. Transducers are typically used in applications where the control system and the actuator use different types of signals. A control valve consists of several components, including the valve body, trim, actuator, and accessories. The valve body is the main component that houses the trim and provides the interface with the process piping. The trim includes the valve plug, seat, stem, and other components that control the flow through the valve. The actuator is responsible for moving the valve plug to adjust the flow rate. Accessories include positioners, transmitters, and other devices that enhance the valve's performance. Types of control valves. There are several types of control valves, each with its own specific design and application. 1. Globe valve. The globe valve is a versatile valve that can be used in a variety of applications. 1. It is designed with a globe-shaped body and a movable disc or plug that controls the flow of fluid or gas through the valve. 1. Globe valves can be used for both on-off and throttling applications. 2. Ball valve. The ball valve is a rotary valve that is designed with a spherical ball inside the valve body. 2. The ball has a hole or port through the center that allows fluid or gas to pass through when the valve is open. 2. Ball valves are typically used for on-off applications. 3. Butterfly valve. The butterfly valve is a quarter-turn valve that is designed with a disc that rotates around an axis perpendicular to the flow of fluid or gas. 3. When the valve is open, the disc is parallel to the flow, allowing fluid or gas to pass through. 3. When the valve is closed, the disc is perpendicular to the flow, blocking the flow of fluid or gas. 4. Diaphragm valve. The diaphragm valve is a type of valve that is designed with a flexible diaphragm that separates the valve body from the fluid or gas being controlled. 4. The diaphragm is attached to a stem that controls the position of a disc or plug inside the valve body. 5. Pinch valve. The pinch valve is a type of valve that is designed with a sleeve that is pinched or squeezed by a mechanism to control the flow of fluid or gas through the valve. 5. Pinch valves are typically used in applications where the fluid being controlled is abrasive or corrosive. 6. Needle valve. The needle valve is a type of valve that is designed with a long, tapered needle-shaped stem that is used to regulate the flow of fluid or gas through the valve. 6. Needle valves are typically used in applications where precise flow control is required. 7. Control valve with actuator. All of the above types of valves can be equipped with an actuator, which is used to control the position of the valve disc or plug. 7. Actuators can be pneumatic, hydraulic, or electric and are used to provide the force necessary to move the valve. 8. Solenoid valve. A solenoid valve is a type of control valve that is operated by an electric solenoid. 8. It is typically used to control the flow of air, water, or other fluids in a system. 8. Solenoid valves are often used in automated systems, such as irrigation systems, where they can be used to turn the flow of water on and off at specific times. 9. Check valve. A check valve is a type of control valve that is used to prevent backflow in a system. 9. It allows fluid or gas to flow in one direction, but automatically closes when the flow is reversed, preventing backflow. 9. Check valves are often used in applications where it is critical to prevent contamination of a fluid or gas, such as in the food and pharmaceutical industries. 10. Relief valve. A relief valve is a type of control valve that is used to protect a system from overpressure. 10. It is designed to open at a specific pressure to release excess pressure in the system, preventing damage to the system or equipment. 10. Relief valves are often used in pressure vessels, pipelines, and other applications where pressure can build up. 11. Pressure-reducing valve. A pressure-reducing valve is a type of control valve that is used to reduce the pressure of a fluid or gas in a system. 11. It is designed to maintain a constant downstream pressure, regardless of fluctuations in the upstream pressure. 11. Pressure-reducing valves are often used in water distribution systems, gas pipelines, and other applications where maintaining a constant pressure is important. 12. Flow control valve. A flow control valve is a type of control valve that is used to regulate the flow of fluid or gas in a system. 12. It is typically used in applications where precise flow control is required, such as in chemical processing, food and beverage production, and other industries. 13. Angle valve. An angle valve is a type of control valve that is designed with an angled body. 13. It is often used in applications where space is limited, as the angled body allows the valve to be installed in tight spaces. 13. Angle valves are commonly used in plumbing and heating systems. 14. Three-way valve. A three-way valve is a type of control valve that is designed with 3 ports, an inlet, an outlet, and a common port. 14. It is typically used to control the flow of fluid or gas between 2 different systems or applications. 14. Three-way valves are often used in HVAC systems, process control systems, and other applications where 2 different flows need to be combined or separated. 15. Four-way valve. A four-way valve is a type of control valve that is designed with 4 ports, 2 inlets and 2 outlets. 15. It is typically used to control the flow of fluid or gas between 2 different systems or applications, and can also be used to reverse the flow of fluid or gas. 15. Four-way valves are often used in pneumatic systems, hydraulic systems, and other applications where fluid or gas needs to be directed in multiple directions. 16. High-performance valve. A high-performance valve is a type of control valve that is designed for use in high-pressure, high-temperature, and high-flow applications. 16. These valves are often made from special materials, such as stainless steel or titanium, and are designed to withstand extreme conditions. 16. High-performance valves are commonly used in chemical processing, oil and gas production, and other industries. 17. Cryogenic valve. A cryogenic valve is a type of control valve that is designed for use in low-temperature applications. 17. These valves are typically used in systems that handle cryogenic fluids, such as liquid nitrogen or liquid oxygen. 17. Cryogenic valves are often made from special materials, such as stainless steel or nickel alloys, and are designed to operate at extremely low temperatures. 18. Motorized valve. A motorized valve is a type of control valve that is operated by an electric motor. 18. These valves are typically used in HVAC systems, where they can be used to control the flow of water or air through the system. 18. Motorized valves can be operated remotely, allowing for easy control of the system from a central location. 19. Bellows valve. A bellows valve is a type of control valve that uses a bellows element to provide a seal between the valve stem and the valve body. 19. The bellows element is typically made from metal and is designed to be flexible, allowing it to move with the valve stem as it opens and closes. 19. Bellows valves are often used in applications where a leak-tight seal is critical, such as in the chemical and pharmaceutical industries. 20. Diaphragm valve. A diaphragm valve is a type of control valve that uses a flexible diaphragm to control the flow of fluid or gas through the valve. 20. The diaphragm is typically made from rubber or plastic and is designed to be flexible, allowing it to move up and down as the valve opens and closes. 20. Diaphragm valves are often used in applications where contamination of the fluid or gas is a concern, such as in the food and beverage industry. Advantage. There are several benefits of using control valves in industrial processes. 1. Precise control. Control valves allow for precise control of process variables such as flow rates, pressure, and temperature. 1. This level of control is necessary in many industries to ensure product quality, safety, and efficiency. 2. Energy efficiency. Control valves can help reduce energy consumption by controlling the flow rates and pressure of fluids and gases. 2. By optimizing the control valve selection, installation, and maintenance, energy costs can be reduced, leading to significant savings. 3. Improved safety. Proper selection, installation, and maintenance of control valves can enhance safety in the workplace. 3. Control valves can help prevent accidents and injuries caused by leaks, overpressure, or exposure to hazardous materials. 4. Enhanced process performance. Control valves can enhance process performance by ensuring accurate control of process variables. 4. This can lead to improved product quality, reduced waste, and increased productivity. 5. Flexibility. Control valves can be used in a wide range of applications across many industries. 5. With the use of different types of valves, sizes, and materials of construction, control valves can be customized to meet specific process requirements. 6. Remote operation. With the use of wireless sensors and actuators, control valves can be operated remotely, reducing the need for manual adjustments and improving operator safety. Overall, the use of control valves in industrial processes can lead to significant benefits, including precise control, energy efficiency, improved safety, enhanced process performance, flexibility, and remote operation. Disadvantage. While there are many benefits to using control valves, there are also a few potential disadvantages to consider. Cost. Control valves can be expensive, particularly when additional accessories are required. The cost of installation, maintenance, and repair can also be significant. Complexity. Control valves can be complex and require specialized knowledge for proper selection, installation, and maintenance. Improper installation or maintenance can lead to valve failure or other issues. Maintenance. Control valves require regular maintenance to ensure proper operation. This can be time-consuming and require specialized expertise. Compatibility. Control valves must be compatible with the process fluid or gas being controlled. Choosing the wrong type of valve or material of construction can lead to corrosion, leaks, or other issues. Noise and vibration. Control valves can generate noise and vibration during operation, which can be a concern in some applications. Control signal dependency. Control valves rely on a control signal to adjust their position and control flow rates. If the control signal is lost or incorrect, the valve may not operate as intended, leading to process issues or safety concerns. While these disadvantages should be considered when using control valves, they can be managed with proper selection, installation, and maintenance. Control valve operation. The operation of a control valve involves a complex interplay of fluid dynamics, mechanical engineering, and control theory. The valve's trim is designed to provide a controlled pressure drop that enables precise control of the flow rate. The actuator moves the valve plug in response to a signal from the controller. The controller uses feedback from sensors to adjust the valve position to maintain the desired process parameters. Control valves are essential components of many industrial processes that require precise control of flow rates, pressure, and temperature. They are complex devices that require careful design, installation, and maintenance. Understanding the basics of control valves and their operation is critical for ensuring the safe and efficient operation of industrial processes. Most popular brands. There are many reputable brands that manufacture control valves for industrial applications. Here are a few of the most popular brands. Emerson. Emerson is a global technology and engineering company that produces a range of products, including control valves. They offer a variety of valve types, sizes, and materials of construction, and their control valves are widely used in the oil and gas, chemical, and power generation industries. Fisher. Fisher, a subsidiary of Emerson, is a leading manufacturer of control valves and other industrial process equipment. They offer a range of valve types, sizes, and materials of construction, and their control valves are widely used in the oil and gas, chemical, and petrochemical industries. Samson is a German company that produces a range of industrial control valves, including globe, angle, and rotary valves. They offer a variety of valve sizes, materials, and control options, and their valves are widely used in the chemical, petrochemical, and pharmaceutical industries. Flowserve is a global provider of flow control products, including control valves. They offer a variety of valve types, sizes, and materials of construction, and their control valves are widely used in the oil and gas, chemical, and power generation industries. Metso is a Finnish company that produces a range of industrial process equipment, including control valves. They offer a variety of valve types, sizes, and materials of construction, and their control valves are widely used in the oil and gas, chemical, and pulp and paper industries. These are just a few examples of popular brands that manufacture control valves for industrial applications. Other well-known brands include Honeywell, Siemens, ABB, and Spirax-Sarco. Here are a few more popular brands that manufacture control valves for industrial applications. Voltec is a brand of Flowserve that specializes in control valves for the oil and gas, chemical, and petrochemical industries. They offer a range of valve types, sizes, and materials of construction, and their control valves are known for their reliability and durability. Mason Island is a brand of Baker Hughes that produces a range of industrial control valves. They offer a variety of valve types, sizes, and materials of construction, and their control valves are widely used in the oil and gas, chemical, and power generation industries. Belimo is a Swiss company that specializes in control valves and actuators for HVAC and building automation applications. They offer a range of valve types, sizes, and materials of construction, and their valves are known for their energy efficiency and reliability. Spirax-Sarco is a global provider of steam system solutions, including control valves. They offer a variety of valve types, sizes, and materials of construction, and their control valves are widely used in the chemical, food and beverage, and pharmaceutical industries. Bray is a U.S.-based company that produces a range of industrial control valves, including ball valves, butterfly valves, and knife gate valves. They offer a variety of valve sizes, materials, and control options, and their valves are widely used in the oil and gas, chemical, and water and wastewater industries. These are just a few more examples of popular brands that manufacture control valves for industrial applications. The selection of a particular brand will depend on the specific application and requirements of the process.